Assalamu alaikum students, my name is Fasabat and today we are going to proceed towards the completion of the remaining numericals of the chapter 11, and the name of the chapter is Acoustic Dynamics or Sound. So in this record, I'm going to incept, I'm going to begin with the numerical 11.3, and the number 11.3 here is the number on your screen on the Excel sheet. So first of all, what did the examiner ask to us in that particular numerical? So for this purpose, I'm going to read the statement of the numerical 11.3, and the statement is: at a particular temperature, the speed of sound in air is approximately 330 meters per second. So in the given data portion, I have written magnitude of the speed of the sound in air is equivalent to, as we know, in physics, in mechanics, the symbol which is used to represent the velocity or the speed of any particular entity or factor is small v. So as it is the approximate speed or the average speed, so I have written it as v average is equivalent to 330 meters per second. If the wavelength of a note or a sound is 5 centimeters, calculate the frequency of the sound wave. So it's a very simplest, it's a very unique, it's a very feasible, it's a very convenient numerical of the chapter 11. So it's a very straightforward. So the examiner has given the wavelength of the wave, which is equivalent to lambda is equivalent to 5 centimeters. As we know, in SI system, the units used to express the magnitude of wavelength or the distance or the length of a path between two positions or locations or position vectors is meters. So to convert centimeters into meters, I have to put the value of centi, which is in standard or SI prefixes. 1 centi is equivalent to 10 raised to the power minus 2. So by replacing or by substituting the powers of 10 as minus 2 in replacement to centi, I'll get the answer of 5 centimeters in meters, which is equivalent to 0.05 meters. So, whenever you put the value in replacement to prefixes, the standard values, then you have to write, you have to indicate, or you have to represent an indicator on the right hand side as a standard reference. So I have written it as a standard reference. 1 centi is equivalent to 10 raised to the power minus 2. Okay. What we have to find, we have to calculate the frequency of the sound wave. Frequency of the sound waves is equivalent to small f is equal to, we have to find. So in calculation using formula, what is the formula? As we have to find the magnitude of the frequency of the sound wave, and we have given with the wavelength of the sound and the average speed of the sound, which is in meter per second. So we'll use the formula average speed is equal to frequency multiplied with the wavelength. So as on the right hand side, we can see that the wavelength is multiplying with the frequency. So to find the frequency, and by shifting the wavelength on the left hand side of the equation, then as it is multiplied on the right hand side, so by shifting it on towards the left hand side, it will be divided with the factor of average speed. So by putting values, we'll get the answer 6600 hertz. How that particular answer is derived? So as we know that the frequency is equivalent to average speed divided by wavelength. So average speed is in meter per second, 330 divided by wavelength, which is 0.05 in meters. So we'll get the answer. So we'll get the answer in hertz, which is 6600 hertz. As it is not in the standard scientific form, so you have to write the answer in standard scientific form. And what is the standard scientific form? Standard scientific form states that the numbers should be expressed in the powers of 10, multiplied with another number which should lie within the domain from 1 to 10. So to convert that particular magnitude into the standard scientific form, we have to shift, or we have to transfer the decimal point from the very right hand side towards the left hand side. So by shifting the decimal point through 3 decimal places, the number will be converted into 6.6 multiplied by 10 is power plus 3 hertz. As we know that as a decimal point is whenever the decimal point is shifted towards left, the powers of 10 is expressed in positive numbers. So the number 6600 hertz in standard scientific form can be written as 6.6 multiplied by 10 is power plus 3 hertz. So that is the answer. And what else the examiner has asked? The examiner asked, is this frequency in the audible frequency in the audible range of the human ear. So as we know that the audible frequency range of human is from 20 hertz to the maximum threshold of 20,000 hertz. And you know very well that 6,600 lies between 20 hertz to 20,000 hertz. So yes, the answer is yes, the frequency of that particular sound is the frequency of that particular sound lies within the audible frequency range of human. So that is the end of the numerical 11.3. Now we are shifting towards the numerical 11.4. And what does the examiner ask? Or what did the examiner ask in the numerical 11.4? The examiner asked, a doctor counts 72 heartbeats in 1 minute. Calculate the frequency and the period of the heartbeats. So number of the heartbeats is equivalent to small n is equivalent to 72. As we know very well, there is no specific unit or there is no unit in SI, in FPS or in SCGS system per number. So number of heartbeats is equivalent to 72. It is written without any specific unit because there is no unit for number. What else the examiner has given to us? The examiner has said in the numerical that magnitude of the total length of time required to complete the 72 vibrations is approximately 60 seconds. So I have written it on a very direct basis as 60 seconds because 1 minute is equivalent to 60 seconds. But you should write 1 minute first, then convert the 1 minute into 60 seconds. So that is the formal procedure to convert any particular unit into the SI unit. So what we have to find, I have to find the magnitude of the frequency of the heartbeats, which is equivalent to small f is equal to, we have to find, and the time period of the heartbeats, which is the time taken to complete one vibration. First of all, what is the formula of the generic frequency or the channel frequency to calculate the generic or channel frequency? The formula is number of vibrations divided by the total length of time or total extent of time or the total period of time to complete these number of vibrations. So by putting values, number of vibrations is 72 divided by total length of time to complete these length of vibrations. So the frequency is 1.2 hertz, which means that every 1.2 vibrations required 1 second to complete, or in 1 second, 1.2 vibrations of the total 1.2 heartbeats of the total heartbeats have will be completed. So after, we can say that by seeing or by scrutinizing or by doing a proper appraisal of the magnitude 1.2 hertz, we can pass a statement, we can pass an argument that 1.2 heartbeats of the total number of heartbeats will be completed in every 1 second. So what is the time period? What is the time taken to complete one vibration? For that particular purpose, I have to take the inverse of the frequency. So the inverse of the frequency is 1, first of all, 1 divided by the frequency 1.2. I'll get the magnitude of the time period as 0.833 seconds. So I'm going to restrict it up to 2 decimal places. So 0.83 seconds. Okay. So that is the end. That's a very short, that's a very simplest, another very simplest, you can say that, and the very simple or a convenient numerical of the chapter. So it can be asked in a short question as well as in the long question as well. Okay. So now I'm going to begin the numerical 11.5. So the statement is, a marine survey ship sends a sound wave straight to the seabed. It receives an echo 1.5 seconds later. The speed of sound in seawater is 1500 meters per second. Find the depth of the sea at this position or location. So magnitude, for example, I'm speaking, then my vocal cord is continuously vibrating and it is shifting the vibrational kinetic energy to the particles of the air. And my sound in the form of compressions and reflections is going towards a screen. And after hitting the screen, it will be bounced back towards me. So the examiner said that from the surface of the sea, if we send the sonic waves or the sound waves towards the seabed, then starting from the surface of the sea and going downwards towards the seabed, the magnitude of time taken by the sound waves to start their journey from the surface of the sea and to end their journey on that particular destination, which is the initial or the inception point, which is the surface of the sea, they require the total time, which is approximately 1.5 seconds. Okay. Now it is the total time taken to start the journey from the surface of the sea and then going towards the seabed. Then after hitting or after touching the seabed, the sound waves will be bounced back towards the surface of the sea. And the total time taken to start the journey from the surface of the sea, then going downwards and then coming back towards the surface of the sea, they require the total time taken, which is approximately 1.5 seconds. Okay. The examiner said magnitude of the speed of sound in sea is approximately average speed 1500 meter per second. So first of all, what did the examiner ask? To calculate magnitude of the depth of the sea. So that is the height of the sea from the surface of the sea towards the seabed. Okay, we have to calculate the depth of the sea. Means we have to find the one-way distance. If we send the sound waves from here to there and then they go downwards, then after reflecting or hitting the surface of the sea, and then the sound waves will be bounced back towards the surface, towards the sea surface. So it is the total distance covered from the surface of the sea towards the seabed and then coming towards the surface of the sea. So that is the total distance covered. We have to calculate the distance covered of one go. So to calculate the distance covered of one go, we will have, or we will, you can say that we will divide the total distance covered after calculating with a factor of 2 so that we can get the magnitude of the distance covered of one go journey, or the one go, you can say that. Okay. So magnitude of the depth of the sea we have to find. So using formula, total distance covered is equivalent to average speed multiplied by total time taken to cover the distance. By putting values, I'll get the answer, and the answer is time taken, total time taken to cover the distance multiplied by the average speed. And the answer is 2250 meters. So to calculate the depth of the sea, which is the total distance of one go, or the total distance of one way journey, and it is the total distance covered divided by the factor of 2 will get, if I am assuming that the average speed isn't changing during the whole two parts of the journey, and the time taken, if the average speed is not changing, it means that the same, you can say that the same type of hurdles will be faced by the sound waves in the first half of the journey and in the second half of the journey. Then the magnitude of speed of the sound wave will remain the same. So if the magnitude of speed of the wave remains the same, then the total distance covered in the first half and the total distance covered in the second half, to cover the total distance covered in the second half and the first half, the sound waves will require the same magnitude of time. See? Okay.